In this video, we're going to take the information that we entered into a schematic and we're going to transfer it to UltiBoard and start working on our layout. So if you remember from last time, we entered a schematic into schematic capture. This really doesn't make a whole lot of sense. It's just a sample thing. Don't worry about what it does. Once you've entered a schematic, you can transfer the important information over to UltiBoard in one of two ways. So going up here into the menus, go across the menu, you can see that there's a transfer button. You click down on that and you can transfer to UltiBoard or you can forward annotate to UltiBoard. Now a transfer will take all the information and it will start a brand new layout and it'll dump all the parts in up in the corner. Since we've never done this one before, that's what we're going to do. Once you've started on a layout and you want to take changes over that you made in the schematic, then what you would do is you would forward annotate. So with forward annotate, you can make changes in your schematic and then import those changes over into the layout, and it won't rip everything up and start over. It'll just kind of go in and update things. So transfer is a fresh start. Annotate is an update. So I'm going to do a transfer to UltiBoard. And it asks you to save a file called an UNet, which is a net list. Just press save. I don't have UltiBoard open at the moment, so what it'll do is it will open UltiBoard and it will bring the information over. So here we go, it's opening UltiBoard. It says it's importing the net list, and the net list is the names of the wires and a list of what pins are connected to each wire. So net 0 here, if you take a look at this here, net 0 has J1 pin 5, C1 pin positive. So basically the net list is just a list of connections. When you do a transfer, it takes the connection list and it takes the package information over into UltiBoard. Once you're in UltiBoard, you're dealing with physical parts, and it doesn't really matter if it's a transistor anymore or a chip. You're going to make the connections regardless of what the part is. So you've kind of lost that bit of information on functionality, and now you're looking at the physical parts. So I'm going to say OK here, bring in the net list. So what it does is it brings in all the parts and it drops them down up here in the corner, and it puts down a board outline. So this yellow box here is a board outline, which is usually 3 by 4 inches or something like that. It just throws down any size. You can change it. So here we are. We've dropped down our parts. Now I find, I don't know if you can see it on my video here, but there's dots on the screen, which is the grid for alignment. I find that a little bit distracting. So I'm just going to turn the grid off, and now it's a black screen. So now once you're in UltiBoard, it really is just a drawing package like Visio or Microsoft Word. You can draw little things. So you got to think of it more as a drawing package than an electronics package. You can grab objects. So like a drawing package, you can grab objects and you can drag them around as a group. You can grab one object and you can move it. You can zoom in here on this object. This is the capacitor. You can grab the name separately and move it around. Right now I can't. And the reason for that is if you go up here in the corner and look at these, now your menus might be in a different place. You can turn selection enable on and off for different object types. It's kind of frustrating when you're drawing something. It's kind of frustrating when you're trying to do something and you come over here to grab this capacitor and you grab the name and you just move the name around, and then you go, Control Z will undo it. And then you get in there and you grab the part, or maybe you accidentally grab the pad. You're trying to grab the pad and it says it can't move pads. So usually when I'm doing placement, which is figuring out where your parts go, I will basically have it so I can only choose chips, and I will deselect everything else so that I can't accidentally grab it. So now I can grab only the whole part. I can't grab the name. I can't grab a pad. So that's usually handy to start with. Okay, this was a pretty simple product, only about 4 parts. When UltiBoard starts and it puts some parts in, you'll see that here's your parts, and there's these little yellow lines between them. This is what's called a rat's nest. And a rat's nest is showing you connection information, and it's showing you the closest connection. So for example here, this capacitor pin here, the bottom pin on this capacitor, it's connected to this pin, and this pin. If I put the capacitor over here, what it's doing is it's drawing the most direct connection. So the connection between these points would probably be from here, going up to here, and then over here down to here. So this guy here says a trace should go this way and go this way because I've put him in between those 2 parts. If I move that guy over to the other side, you can see it's changed its mind now, and it's saying, oh, you should probably put a trace here and a trace here. That would make more sense based on where the part is. So what you're doing when you do placement, figuring out where your parts go, Control R will rotate it, is you're trying to basically place the parts to keep everything close together and minimize the connection crossovers. And it's always a balance or a trade-off between these 2 things, between distance and complexity of routing. So I'm seeing that this guy here has a couple of lines that kind of goes to this connector. And so what I would probably do is maybe I would put him closer to the connector like so. And then I might rotate him like so. And this connector, let me flip that around. Okay, so that guy, flip him around. And let's do this guy here. Okay, that's not bad. I've kind of got everything close and nothing really crosses over. And so if I like that, what I can do is I can start routing some lines to see how it works. So when you're routing lines, when you're routing traces, you can route traces on the top side of the circuit board or on the bottom side of the circuit board. Components are usually placed only on one side because this reduces cost to manufacture. And you can see here, this component here, it has green pads, so it's on the top side of the circuit board. If I take him and if I Alt-S, it's flipped it over and now it's all of a sudden it's red. It's now on the bottom side of the board. When you are doing layout, you are looking at the board as though it's layers, and you are looking basically straight down at the circuit board from the top side. And the layers have colors so that you have an idea when you're routing it of which side you're doing. So if you want to take a look at the layers, if you go up into the view here, you can see there's this thing called Design Toolbox. So if I bring up the Design Toolbox, it shows me the names of a whole bunch of layers. So here's my circuit board. There's the copper top layer. That's green. There's the copper bottom. That's red. This is a 2-sided circuit board. Basically, it has copper only on top and bottom. You can have 4-layer circuit boards, and then they have layers in the middle of the circuit board. This is only 2-layer. So here's the copper top. Here's the copper bottom. There's silk screen top, 3D info. So there's a whole bunch of layers here that you're looking at basically. So the circuit board has layers stacked up, and you're looking at information from the top side down through the top layer from one side. and you can turn off layers so that you kind of eliminate noise and things. And you can disable them from being picked. So in order to run, so here I've got all my parts on the top side. Now I'm going to run a trace. So I go up in here. First of all, when I run a trace, I need to pick which side this thing is going on, or which layer. You need to select which is the active layer, and it's the one you're working on. So I'm just going to double click on copper top, and you can see that over here, it popped up copper top. That means I'm now working on the copper top layer. Now I can come up over here and grab this wire tool here, and then I can go down to a component. See that when I come in close to a component, it puts a little X there, so it'll automatically connect to that point. You can see I'm now routing a trace. So this is a green trace, so it's on the top side. Now, you can see that the trace, it will exit the part only at even for multiples of 45 degrees. So here I can go straight up, or I can exit on this 45, exit on that 2 times 45, 3 times 45. That you can change if you hit the space bar. So I've hit the space bar, and now I can exit on any angle. So if I wanted to, I could route this trace like this. Dum da dum da dum da dum da dum dum. I'm getting there. I'm getting there. There we go. And once it's hit the X here, that means you've completed that route. And when I hit the escape thing here, it disconnects the routing wire. If I didn't hit the escape, I could go on to carry on to make another connection. So let's say this trace here, it goes from here to here, and then it goes from there to there and there to there. So I could come out here and I could say, oh, make that connection, make that connection, make that connection. So I didn't have to draw a new one each time. I can continue on from one point to another. I can also put a trace on the other side of the board. So here I'm going to do a trace. Now, I kind of showed you this trace here, how you could exit at any point. It's pretty ugly. No one would ever do that. Here I can exit only on 90-degree angles. And if I hit the space bar again, it's every 90 degrees on a 45. Space bar again. Now I'm back to multiples of 45. This is kind of what you should be using. So I'm going to come out this way on this 45-degree angle. Oops. I'm just going to do this. I said I was going to do it on the other side of the board. So I'll take that off. So I'm going to route a trace on the copper bottom. Now the DB9, when you looked at it before, when I showed you the parts in schematic capture, you saw that it was a through-hole part. It has pins that go right through the board. So you can route from the DB9, and this resistor here, it's got a hole in the middle. You can start routing from either side of the circuit board. The hole on a component has a tiny little piece of copper that's been plated into the inside of the hole. So it is conductive through the hole. When you solder these parts to the circuit board, the hole fills with solder and you get a pretty good connection through it that can take a fair bit of current. So I'm going to start routing a trace from here on the red side of the board, which is the bottom side of the board. Now, I cannot, although this looks like this is going to be a connection. Here you go. I connected it, Mr. Nelson. The problem is that this trace here is on the bottom side of the board, and this capacitor is on the top side of the board, and this is a surface mount component. It has no hole down to the bottom side. So basically, the capacitor is here, and the trace is here, and they're separated in the Z direction, and there is no connection between them. If I turn off the copper top, if I dim down the copper top and turn it off, you can see that that trace basically goes over to here, and there's nothing there. So what you need to do, if you're going to route to a surface mount part from the bottom side, Okay, now I'm trying to pick an old trace. I'm trying to select traces now. But when I did placement, I said, let's only select components. Now that I'm routing traces, I want to enable select traces. And now I can grab the traces and I can move the traces around. I can delete them. I can bring up the properties of a trace. It's a drawing tool, kind of like Visio, that once you put an object down, if you right click on it, you can bring up the properties of that object and then you can edit them. So for example here, this part of this trace here, if I bring up the properties of that segment of trace, it pops up a window here and it says here's the trace properties. It tells me the start point, the end point with XY locations. If I go into general, the width can be used net settings, or I'm going to make this one 25,000. And that is in mils. If you read your thing from David L. Jones, you'll know what mils are. If you don't, then you should read the thing from David L. Jones. Okay, so you can see that I pulled up the properties of this trace and I said make it this thick, and now it's thicker. Okay, so there's two ways to finish this route. One of the ways I could do it is I could start routing from the bottom side of the board from where the old trace was. So I've started from the bottom side of the board. If you hit F2, F2 will change the trace that you're routing to the opposite side of the board. So if you hit F2 after you've started routing this trace, what it will do is it will route it on the top side of the board and it will automatically put a via in for you. So here I'm going to connect it to there. You can see that it routed the trace. It put a hole through the board and it plated. It's going to plate the inside of it when it's manufactured. So this is a connection through the board. So this is how you can go from top to bottom. And I can route. So I'm going to route over here. So now I'm back on the green layer. There's an easy route. There's an easy, if I route over here, it's over here, I guess, back here. If I route over here, if I put two traces on the green side of the board, the top side of the board, that cross over each other, that is going to be a short. So that's not going to work. So what I have to do here is I will put down one side of this here, and then I will F2, which is one of the hotkeys to change sides, and then I will basically finish it off here. So in order to get over a trace, you need to go to the other side of the board, and then you can go over a trace. If you have really good placement, you will minimize these. So there you go. You can see that I've routed everything. Oh, have I routed everything? I can see that there's a little bit of a rat's nest in here between these two pins. That is hard to see. It's also really hard to see. It's harder to see if I did this. Let me just take this out. Oh, darn. I can't delete that via because I need to turn on selecting vias. So now I've turned on selecting vias. I can come over here, take the via out. So here I'm going to go from here to here. That's on the red. That is not a connection, but it's really kind of hard to see that the rat's nest is still there. So what happens there, if you do this, what it does is it puts the rat's nest in, but what it'll do is it'll basically create like a little triangle. So here's the yellow rat's nest line saying this point on the bottom side needs to be connected to this point on the top side. These are kind of hard to see. And often I've had students submit layouts where they think they've done it, but they haven't quite finished everything. And they're missing one of these. There's another thing called the spreadsheet view. And now the spreadsheet view is basically like a table or a list view of information on the circuit board, so that you can look at information not visually or graphically, but in a list. If I bring up the nets in the list view, here's the list of the nets. It's a small circuit, And again, the nets is essentially wire connections. How many wires are there on this board? There's 1, 2, 3, 4, 5. Oh, that is the same piece of wire. 1, 2, 3, 4, 5. There's 5 wires on the circuit board. And I think that I've missed one, because if I look down at the nest here, the net list, there are 6 nets listed, which means there's 6 wires on the circuit board that need connecting up. If you look at the net list, what happens is when you start completing the net list and you fully route it, what happens is it turns bright green. So these bottom 4 here, those nets are completed. You've routed them 100%. These 2 guys here, you're missing something with those. So net 0, and if you click on the net here, you can see it draws a little box over behind me that basically shows you where the net is on the circuit board. And you can also highlight it on the actual layout. So here, net 0, I've highlighted on the layout. I go in and I'm looking at this and I say to myself, what's wrong? What's wrong? I keep looking and it's like, okay, I need to flip this to the other side. Now I can select a trace here, and if I go Alt-S, what it'll do is that's basically swap sides. It will flip that trace to the other side, and it will put in the vias required to do it. So I've Alt-S to this one. It's now connected to the top, comes over here to the via. It's now connected to the bottom as well. So now I've just got this one net up over here. Let me take a look for that one. Oh, that's these 2 guys here, these 2 pins. So what I'm going to do is I am going to, oh, wrong side, F2, flip sides. I am going to move that down to the way. I could run a quick trace across here, but I've found that after the part gets soldered on the board, it's kind of hard to tell if that's a trace or some kind of piece of crap caught between the pins. So usually what I like to do with something like that is I like to bring it out outside of the chip so it's visible, and I make the connection outside rather than underneath. If I can avoid going underneath, then if I'm trying to troubleshoot this board, I can visually see that there's a connection there, and I don't end up cutting that trace out. I actually did this once where I'm going, is there something in there? And I cut it out, and then I had to bring up the schematic and realize it's, no, those 2 points really were connected. If the guy doing the layout had just done this, I'd have known that right away. So there you go. There's kind of a short introduction to layout. You come in, you place your parts, go for minimum crossovers, short distance, doing a trade-off between the 2. You start routing traces between points, one on the top side, one on the bottom side. So I think I'm going to end this video here. And in the next one, I'm going to show you a couple more features that you will use when you get into it.